In this video, we will study three diagrams without replacement for two color balls with sampling of 2. An urn contains 12 blue balls and 8 red balls. 2 balls are picked up at random without returning the balls to the urn. First question, what is the number of all possible outcomes or the number of elements in the sample space? First, we number the balls to make them distinguishable. So we number red balls from 1 to 8 and blue balls from 1 to 12, or we number all of them from 1 to 20. So let us first examine the drawing process. The balls may come out in the order of blue first and red second, or red first and blue second. So that means the balls come out of the urn in order. So the actual sample space is composed of ordered elements, and the outcome of the probability experiment is ordered and without replacement. So that means we must use a formula which requires order and no replacement, and that is the permutation formula of n element taken r at a time and without replacement. So the number of elements in the sample space for the case of order can be computed from the permutation formula under the condition of withdrawing without replacement. So we have n, the number of object or the number of population, and that is 20. And r, the sampling size, this is 2, so we are sampling 2 objects out of 20. And we use the permutation formula, we substitute n and r, so we have a 20 permuted 2 at a time, and that is equal to 20 times 19, so the number of elements in the sample space is 380. Question number 2, find the probability of the joint outcome events using the tree diagram. So let B represents the drawing blue ball and R represents the drawing red ball. So let us use the tree diagram, starting with 12 blue and 8 red. So the total number of balls in the beginning is 20. So let us pick the first ball. So we have now the first draw, and we picked one ball without return, so the total number of remaining balls is 20 minus 1, and that is 19 balls remaining. We may pick blue or red, so let us create these cells to write the number of remaining balls after each withdraw. So if we draw blue, then the number of remaining blue would be 11, so this is a 12 minus 1, 11, and the number of remaining red will be 8, because we picked no red. But if we pick one red, then the number of remaining red would be 8 minus 1, and that is 7, and the number of remaining blue would be 12. So now we can see that 12 plus 7 is 19, and 11 plus 8 is also 19. So for each possibilities, the number of balls must always be equal to the total number of remaining balls, which is 19. For the second draw, we may again pick blue or red, and now we can get all joint outcomes, so we may get blue and blue, blue first and red second, and so on. And these are all the joint outcome events we are looking for. And now we need to find the probability of each joint outcome event. For the first draw, whether we are picking red or picking blue, we are doing that out of 20 balls. So the probability of picking red will be out of 20, and the probability of picking blue will be out of 20. As for the second draw, we are picking a ball here out of 19. So whatever we pick for the second draw will be out of 19. So now it's very easy to compute the probability for each branch. So what is the probability of picking the first blue? So we have a 12 blue out of 20. And what is the probability of picking the first red ball? We have 8 red, so it is 8 over 20. Now what is the probability of picking one blue here? So we have 11 blue over 19. What is the probability of picking red here? So we have 8 red, so it is 8 over 19. And we keep doing that. For each branch we have 12 over 19 for the blue and 7 over 19 for the red. So using this tree diagram will make it very easy only if we write the number of remaining balls for each branch. Now if we need to find the probability of picking first blue and second blue, we have to highlight the branch which lead to this event, first blue and second blue, and we take the probability of the first branch and the second branch and we multiply them together. And if we want to find the probability of picking blue first and red second, we have to highlight the paths or the branches leading to this event. We take the probability of the first branch and the probability of the second branch, we multiply them together and we get the probability of first blue and second red. And if we need to find the probability of first red and second blue, we highlight the branches leading to this probability and we take the probability of each branch and we multiply them together and we get the probability of first red and second blue. We do the same thing for picking first red and second red. We highlight the path and we multiply the probability of the branches of the path and we get the probability of first red and second red. Now we have the probability of all these events, so we will isolate them and turn them around, organize them more and put them in the sample space. So let's organize them again and write the numerical value of each probability and the name of each event, and this event create partition in the sample space. Question number 3. What is the probability of picking one red and one blue? So we either pick one blue first and red second, or one red first and one blue second. So the union of these two disjoint events create the event of one red and one blue in any order we want. So the probability of this event is the probability of blue first, red second, or red first and blue second, which is the sum of these probabilities, and that is equal to 0.50. Question number 4. What is the probability of picking at least one red? So we may either pick one red or more, which is two reds. So the union of these events create the event we are looking for, at least one red, and the probability of this event is equal to the sum of all the probabilities of each individual event, and that is 0.65.